Hello students, in this lecture I am going to discuss about the 8051 microcontroller architecture. So here this is the architecture. In this slide I have shown the architecture of 8051 microcontroller. Let me zoom it, yes. So in this architecture you can see there are various registers. We have arithmetic and logic unit, interrupt and serial and timer control block. We have ALU, we have interrupt serial timer control blocks. We have various registers like accumulator, register B, stack pointer, program counter, etc. Various registers are there. So one by one we'll be discussing each and every block. So first I'll start with the special function registers of 8051 microcontroller. So the addresses, as when I was discussing the memory organization part of 8051 microcontroller, I told you that the upper 128 bytes, the upper 128 bytes from the RAM is for special function registers. That is the addresses from 80H to FFH. That is 80H up to FFH. So these addresses, they are allocated for special function registers. Special function registers control specific functions of 8051 microcontroller. And these addresses are above 80H. Why 80H? Because the address 00H27FH are addresses of RAM memory inside the 8051 microcontroller. So the special function registers address will be from 80H to FFH. So these special function registers can be accessed only by direct addressing. So these are, as you can see here in this slide, these all are the special function registers. As you can see, so in this slide, these all are the special function registers of 8051 microcontroller. Like this is the accumulator, then register B, then program status word, then stack pointer. So I am going to discuss each and every register in detail in my next slides. So again you can see one more thing, that each of among these special function registers, there are registers which are marked with this asterisk sign. You can see like accumulator is having this asterisk sign, register B is having that asterisk signs. Not all registers of the special function register are having the asterisk sign. So asterisk, those registers which are having asterisk sign, they are bit addressable, means they can be addressed byte by byte as well as they can be addressed bit by bit. So moving on, so these are the special function registers. Here I have discussed like accumulators. There are two accumulators in 8051 microcontroller, like register A and register B. Then we have program status word, that is PSW. Then input output port registers. They are P0, P1, P2 and P3. Data pointers, they are DPH and DPL. Then we have serial data buffer register like SBUF. Then stack pointer SP, timer registers TH0, TH1 and TL0, TL1. Timer control registers TCON and TMOD. Power and port control PCON and SCON, and interrupt control registers IP and IE. So let's start with the accumulator of 8051 microcontroller. So the accumulator of 8051 microcontroller is a 8-bit register. As you can see, this is the format of the accumulator. So this accumulator, this is a 8-bit register like 1, 2, 3, 4, 5, 6, 7, 8. So this accumulator of 8051 microcontroller is a 8-bit register. What is the purpose of accumulator? Like in microprocessor, in microcontroller also, the result of arithmetic and logic operations performed by ALU is accumulated by this register. Therefore, it is called accumulator register. It is also used to store 8-bit data and to hold one of the operand of ALU units during the arithmetic and logical operation. So its address is E0H. So as you can see, the accumulator, as I've told you, that arithmetic, for performing arithmetic and logical operation, we need two operands. So one of the operand gets stored in the accumulator. So one of the operand is stored in the accumulator. So accumulator is used for storing one of the operands of arithmetic and logical unit. It is used to store the 8-bit data, and it is also used for storing the result of arithmetic and logical operation. So what is the address of accumulator? The address of accumulator, as you can see, it is E0H, and it is bit and byte accessible. How it is bit and byte accessible? You can access the whole accumulator using its address like E0, or you can use its name like A. So you can either access the accumulator as a whole, as a byte, or you can access the accumulator, that is the contents of the accumulator are also bit addressable. So the bit addresses of all the bits of the accumulator are shown here. So these are, since the accumulator is a 8-bit register, every bit of accumulator is having an address. Here you can see E0, E1, E2, E3, E4, E5, E6, E7. So we can address individual bit of accumulator also, or we can address the whole accumulator as a byte also. So it is bit as well as byte accessible. Next register that I am going to discuss is register B. It is a special 8-bit math register. It is used in conjunction with register A as input operand for ALU. Like I've told you that ALU needs two operands. So this accumulator is used for storing one of the operands, and the register B is can also be used for storing the operands of this arithmetic and logic unit. So 8051 microcontroller is having two accumulators, that is register A and register B. So basically 8051 microcontroller has two accumulators, and it forms the accumulator for, that is this register B works as the accumulator for multiplication and division operation. Register B works as an accumulator for multiplication and division operations. For other operations, it is used as general purpose register to store the 8-bit data. So address of register B is, the address of register B is, you can see here, it is F0H. You can see it is F0H, and it is bit as well as byte accessible, just like the register A. So what is bit and byte accessible? Again, you can access the register B as a complete 8-bit register, or you can individually access the bits of the register B using the bit addresses of register B. So you can see this register B, this is the format of register B. This register B is a 8-bit register, and every bit of register B is having the address, this F0, F1, F2, F3. These are the addresses of individual bits of register B. So you can individually access these bits by using their addresses, or you can completely access the register B using its address, that is F0, or using its name. So these are the bit addresses of all the bits of the register B. So I'm ending this class here. We'll continue with the topic of special function registers in my next class also. I'll discuss there about the program status word and program counter. I'm ending this class here. Thank you.